Hello students, welcome to BioWise with Aanchal. Now today I have brought something very interesting, the practical chemistry. Yes, practical chemistry where all the important gases, what are the tests, how are they produced, and what you are supposed to write when the observation is asked in the examination. Now this PowerPoint is you can say it's fit for standard 7, 8, 9 or 10 depending upon how much you want to extract from this video. Okay, the complete detail of all the 9 gases are given here with the methods of their preparation. So without wasting time, let us proceed. Before that, subscribe the channel, like and share with your friends because they also need it. Yes, let's move ahead. Now, first one is the hydrogen gas. Now, hydrogen gas, as you know, is a diatomic gas, right? H2, and it is colorless, odorless, and neutral. Neutral means it has no effect on the litmus paper. The moist red litmus remains red, and the moist blue litmus remains blue. It is highly inflammable gas and it is non-supporter of combustion. You should understand the difference. Hydrogen burns itself, okay, but it does not support combustion like oxygen, and it burns with a pale blue flame and with a pop sound. So whenever what to say, a flame is brought near the hydrogen gas, it burns with a pop sound. This is the observation for hydrogen gas. And how is hydrogen gas produced? By any mash reaction. What is mash? Metal press acid gives salt and hydrogen. Okay, moving ahead. Now here are the certain methods of preparation of the um, gas. You can see here. Now in this video, you can see sodium metal is added to the water and a little bit of phenolphthalein and indicator is added because that helps us to find out whether the color change is taking place or not. This color change tells us that NaOH is produced, which is basic in nature. So this color change is showing the formation of a base. That is why the color has changed. Now let us see, and see sodium has also it has catched fire, right? So this is how the sodium reacts with water. It reacts very vigorously with water, even with cold water. So you can see the active metals like sodium, potassium, and calcium. They all react with water to produce respective bases with the liberation of hydrogen gas. Similarly, another metals, that is less active metals, like magnesium, magnesium reacts with water, hot water, to produce the respective oxide and hydrogen. And lower, it should not be active, it should be lesser active metals like aluminium, zinc, and iron. They all react with water. Steam, red hot metal reacts with steam to produce their respective oxides and hydrogen gas. Okay, so you can understand the difference. The most reactive metals react with cold water. The lesser reactive metal like magnesium reacts with hot water, and lower in the reactivity series, you can see that aluminium, zinc, and iron reacts with steam. The red hot metal reacts with steam to form oxide and hydrogen gas. Now, below that, hydrogen, the copper, they all do not react with water because they lie below the reactivity series, right? So, you know the reactivity series Ka, Na, Ca, Mg, Al, Zn, Fe, Pb, H, Cu, Hg, Ag, Au, Pt. That is Cu, copper, mercury, silver, gold, platinum, they do not react with water. Okay. Now here you can see the active metals with dilute acid. Now whenever this is your mash reaction, that is metal plus acid gives salt and hydrogen. So these are so many reactions. Here is a set of reaction with with the sulfuric acid. And here there are set of reactions with hydrochloric acid. You can pause the video here, write down all the reactions. This will also help you to practice the reaction and also balance the reaction. Now you can see here sodium reacts with the sulfuric acid to form sodium sulfate. It is potassium, sorry. Potassium reacts with sulfuric acid to form potassium sulfate and hydrogen gas. Sodium sulfate and hydrogen gas. Calcium reacts calcium sulfate. Then you have magnesium sulfate, aluminium sulfate, zinc sulfate, iron sulfate. This is iron 2 sulfate. and lead sulfate. Now, lead I have written with red. Reason is they form insoluble salts, which may form a kind of layer over the metal, and the production of hydrogen is reduced. Okay. Similarly, when with hydrochloric acid, you can find sodium forms sodium chloride, calcium forms calcium chloride, magnesium forms magnesium chloride, aluminum chloride, zinc chloride, FeCl2 is ferrous chloride. And again, here an insoluble lead chloride. The reaction does not last very long. Then you have metals, ZAP. Always remember these metals they form amphoteric oxides, right? These metals have a potential to react with concentrated alkali. Same as what it reacted with acid to give you simple salt. Here they react with alkali to give you complex salt. So zinc reacts with sodium hydroxide to form sodium zincate. Then you have aluminium, aluminate, sodium aluminate, sodium plumbite, potassium zincate, potassium aluminate, and potassium plumbite. Now, children, if these kind of salts are given to you, you can easily find out the valencies of these aluminate ion. Now, see here. So, what is the charge of aluminate ion here? Aluminate ion, matlab ye pura will be an aluminate ion. So, this is plus, so this has to be minus. It has minus charge. So, the here aluminate is Al2 minus. ZnO2 2 minus. PbO2 2 minus. Understood? So by seeing the formula also you can find out the charge on the anion formed. And sodium here is Na plus. You know that. What is the cation present here? Na plus. What is the anion present here? Zincate ion, that is ZnO2 2 minus. Understood? Moving to the next, oxygen gas. Now, oxygen is what? It helps you to live. We survive because of oxygen. Combustion, respiration, all takes place because of oxygen. So, oxygen is a colorless, odorless, and neutral gas. It is a supporter of combustion. It does not burn itself, but it supports combustion. And it also turns alkaline paragalol solution brown. So, this is a kind of chemical test for oxygen. You can see here the colorless paragalol changes into brown color, right? And oxygen, the test that you need to write for oxygen is whenever a glowing splint is brought close to the oxygen gas, it rekindles into flame. Yeah, you can write it rekindles the glowing splint. Okay, rekindles means bursting into flame. So rekindles the glowing splint is the observation for oxygen gas. How can you prepare this gas? You can see here. This reddish brown color is the nitrogen dioxide. Along with it, oxygen is also released. Oxygen is a colorless, odorless gas. So it comes out with the nitrogen dioxide reddish brown frame. So we can test here as you can bring a glowing splint. So it will rekindle the glowing splint showing the presence of oxygen. So whenever a nitrate is heated strongly, that is thermal decomposition of nitrates, except sodium and potassium nitrate because they are thermally stable. They do not decompose. Potassium and sodium nitrates are thermally stable. They do not decompose. Understood? So here you can see copper nitrate, calcium nitrate, lead nitrate, zinc nitrate, magnesium nitrate, silver nitrate. Silver nitrate has a different story. It gives you silver instead of silver oxide, and formation of nitrogen dioxide and oxygen is there. But all the other metallic nitrates gives you the metallic oxides and two gases. One is reddish brown nitrogen dioxide and one is oxygen. Now, children, here, if you have to see the color, now lead oxide is a pale yellow color compound. So it's a residue. Basically, when you are heating a substance, a pale yellow residue is formed and a reddish brown gas is evolved along with a gas which rekindles the glowing splint. Similarly, here ZNO. ZNO is yellow when hot and white when cold. How can you differentiate between lead oxide and zinc oxide? Is when both of them appears yellow when they are hot, but when they cool down, zinc oxide becomes white, but lead oxide remains yellow. Okay, so magnesium oxide is a white powder-like material. These are all residues because it is heated. The salt is heated strongly and a residue is left, liberating gases. Understood? So here the term residue is very important along with the observation of the gases. Then there are other reactions in which you can see here, it's a catalytic decomposition reaction where MnO2 is a catalyst. It enhances or increases the rate of decomposition of hydrogen peroxide into water and oxygen. Similarly, when potassium chlorate is heated, that is thermal decomposition of potassium chlorate in the presence of a catalyst, that is manganese dioxide, gives you potassium chloride and oxygen. Then dark brown lead oxide, that is your lead dioxide, gives you yellow lead monoxide, PbO. Similarly, the tri-lead tetraoxide, that is red in color, it decomposes into yellow lead oxide and oxygen gas. Mercuric oxide also decomposes to give you mercury plus oxygen. Children, here O will not be there. Okay? Now, here O will not be there. Okay? Here O will not be there. Fine. So this is the reactions. Then you have got this carbon dioxide. Next gas is carbon dioxide. Now, when you take in oxygen, which gas you give out? That is the concentration of which gas increases in your exhaled air, that is your carbon dioxide. Now, when we inhale 21% of oxygen, and when you exhale, it is around 16% of oxygen. When you inhale, it is about 0.03% of carbon dioxide. When you exhale, it is around 3 to 4% of carbon dioxide. So, concentration of carbon dioxide increases in the exhaled air, right? What is carbon dioxide? Carbon dioxide is a colorless, odorless gas, and it's a non-supporter of combustion. It's an acidic gas. When exposed to moist litmus, it turns moist blue litmus red. Red is danger, red is acid. Okay. Now, what are the different tests you can see? Lime water turns milky. Acidified potassium permanganate remains pink, that is, no effect is seen. And acidified potassium dichromate solution remains orange, that is, no effect is seen. So this is actually what happens. Carbon dioxide and sulfur dioxide gives the first test, that is lime water milky test, positive. So we need to have some other reagent also to test whether it is carbon dioxide or sulfur dioxide. So you can write here the that color, 1 minute. Okay. Now, observation here, colorless, odorless gas released, which turns lime water milky but has no effect on acidified potassium permanganate solution. No effect on potassium permanganate solution and potassium dichromate solution. Remember, they are a little bit acidified. Amount of acid is added to it. So there is no change in color taking place in these two solutions, but lime water is turning milky. Then how is this gas produced? Any metal carbonate or bicarbonate, when it is treated with dilute acid, it gives you salt, carbon dioxide, and water. So here carbon dioxide is released whenever you have acid added to the carbonates. So sodium carbonate, when treated with dilute hydrochloric acid, gives you sodium chloride, water, and carbon dioxide. Lead carbonate, when heated with nitric acid, gives you lead nitrate plus water plus carbon dioxide. Copper carbonate gives you copper sulfate, hydrogen, that is water and carbon dioxide. Ammonium carbonate with HCl gives you ammonium chloride, water and carbon dioxide. Now always remember children, here when the reaction is taking place, here sodium is forming the salt, and here H and CO3 forms a weak acid called H2CO3. It decomposes readily into water and carbon dioxide. So carbon dioxide gas is released. So all the cases, you'll find that there is a chance of formation of carbonic acid. So carbonic acid in the product side, you'll not have it. You'll have it, it decomposes into, you can say it dissociates into water and carbon dioxide. So in all these cases, you can see carbon dioxide and water is formed. Okay, this is how the reaction goes about. Exchanging the partners, double displacement reaction. Okay, Moving to the next, strong heating of metal, that is thermal decomposition of metallic carbonates and bicarbonates, except potassium and sodium. They are very reactive metals, so their compounds are generally stable. So here these carbonates also do not decompose. They're thermally stable. But other carbonates, they decompose into their respective oxides and carbon dioxide. So calcium carbonate into calcium oxide, carbon dioxide, magnesium carbonate, magnesium oxide, carbon dioxide, aluminum carbonate, aluminum oxide, carbon dioxide, calcium bicarbonate, calcium carbonate, water and carbon dioxide. Similarly, magnesium bicarbonate, carbonate, water and carbon dioxide, and sodium bicarbonate, sodium carbonate, water and carbon dioxide. Right? Burning of hydrocarbons. Now, any hydrocarbon, when it burns, hydrocarbon, so it will give you water and carbon dioxide because both are burning in oxygen. So, hydrogen with oxygen, water, carbon with oxygen, carbon dioxide. So, when methane is burned with oxygen, you have water and carbon dioxide formed. Balancing is very important. Okay, the you can see here the balancing, you can balance the reaction, and then again you have this is ethane with what oxygen gives you water and carbon dioxide. This is ethene. This is ethine. No, this is ethene. C2H2, C2H4 is ethene, and C2H2 is ethine. Right. So ethene will give you again water and carbon dioxide. Ethine will also give you water and carbon dioxide. This is ethanol, that is alcohol. Alcohol also gives you carbon dioxide and water. So always remember, any hydrocarbon, when it is burnt in oxygen, it gives you water and carbon dioxide. Sulphur dioxide. Colorless gas with sharp and pungent irritating odor, because sulfur dioxide is a very important gas because it causes acid rain. In acid rain, we have studied that oxides of sulfur and nitrogen causes acid rain. So this sulfur dioxide reacts with the moisture present in your nose and produces acid like sulfurous acid that gives you an irritating feeling in the nose. That is, it has a pungent, sharp, irritating odor, and it is an acidic gas. Okay, here also it turns lime water milky, same as carbon dioxide. Acidified potassium permanganate turns colorless. Okay, you can see here pink to colorless. And here potassium dichromate turns green. So this is a differentiating test between carbon dioxide and sulfur dioxide. What is the observation? Colorless gas release which turns lime water milky, and acidified potassium permanganate from pink to colorless, and potassium dichromate solution from orange to green. Okay, this is what the test for sulfur dioxide. How it is produced, like carbon dioxide was produced from carbonates and bicarbonates, sulfur dioxide is produced from sulfides and bisulfides. So whenever sulfide or a bisulfide reacts with dilute acid, you have the formation of salt and sulfur dioxide. Okay. 1 minute. यहाँ पे there is one. It should be sulfur dioxide. Okay, this is sulfur dioxide. Okay, this is sulfur dioxide. Now here you can see the reactions. Sodium sulfite reacts with dilute HCl to give you NaCl, H2 and SO2. Now here also, children, you can see here H2SO3. Like there H2CO3 was formed, which dissociates into water and carbon dioxide. Here also you have H2SO3 formed, which decomposes into H2O and SO2. Right, so it is also a double displacement reaction that is happening. You can see here H2CO3 gives you H2O and SO2. Then H2SOC, again same thing you can see here, right? You have the formations. So you can have the sulfurous acid which decomposes into water and sulfur dioxide, right? And you have the formation of salt. Basically, these salts are all soluble salts. Yes. Moving next, strong heating of the sulfides. Like you heated carbonates to get carbon dioxide. You heat sulfides, you get sulfur dioxide. You see, you heat bisulfides, that also gives you sulfur dioxide. This is all the reactions. You can pause the video, write all the reactions properly. Yes, and do not write a balanced equation, just write a skeletal equation, then balance it and then check. So it will help you to learn balancing also. So many reactions are together. So you can practice balancing and writing the equations along with me in the PPT, right? Oxides of metals and non-metals by concentrated H2SO4. Concentrated H2SO4 is basically a dehydrating agent. It removes water. So you can see here everywhere the water is produced, right? It removes water and sulfur dioxide gas is released. So here carbon dioxide plus water plus sulfur dioxide. Here also sulfur dioxide plus water. Then here you have copper sulfate and water and sulfur dioxide, zinc sulfate and water and sulfur dioxide. This is how the oxidation of metals and nonmetals by concentrated sulfuric acid is seen. Then there are tests for sulfite ions. It can be detected by formation of white precipitate of barium sulfite and its solubility in mineral acids. Now, whenever barium chloride, now this is how any salt you have taken, whether you find out whether it is a sulfite or not, then you can add barium chloride to it, right? Barium chloride forms white precipitate of the barium sulfite, which confirms the presence of the sulfite ion in the salt, right? Similarly, when you dissolve this white precipitate in HCl, which is a mineral acid, you get a colorless solution. So when this barium sulfate is dissolved in HCl, it gives a colorless solution. It also dissolves in nitric acid to give a colorless solution. So this becomes a test for sulfite ions. Okay. Lime water reaction, as I told you, carbon dioxide and sulfur dioxide both gives positive lime water test. Both turns lime water milky. But when you pass excess of the gas in the lime water, the milkiness disappears. Okay. So you have to be very specific in the question when they are asking whether carbon dioxide is passed in excess or it is passed in lesser amount. So when you pass carbon dioxide through lime water is what? Calcium hydroxide. Lime water, it turns milky because of the formation of insoluble calcium carbonate. Right. Similarly, formation when sulfur dioxide gas is passed through lime water, you have the formation of insoluble calcium sulfite. They form turbidity. So the milkiness appears in the solution. When you pass carbon dioxide, more carbon dioxide or sulfur dioxide, you have the formation of bicarbonates and bisulfites, which are soluble in nature. So what happens? The milkiness disappears. Okay. Milkiness is because of the presence of insoluble salts. When the salts gets dissolved, then the milkiness disappears. That is the lime water test. Now, this table gives you a difference and similarity between carbon dioxide and sulfur dioxide. Odor, carbon dioxide is odorless, both are colorless. So that is also a similarity. Odor, carbon dioxide is odorless and sulfur dioxide has a pungent smell. Lime water, both turns lime water milky. Potassium permanganate, there is no effect, but here you can write pink instead of purple because we take a dilute solution of potassium permanganate, which appears pinkish in color. So instead of purple, you can write here pink. Okay, you can write here pink. Let me write so that it helps you to remember. Instead of purple, write here pink. Okay, pink to colorless. That will be a better option. Then potassium dichromate is orange in color. So carbon dioxide has no effect. You can see the color is not changing, but it changes to green in sulfur dioxide. Moist blue litmus paper turns red. That is showing that carbon dioxide and sulfur dioxide both are acidic in nature. Red litmus has no change in color. So this is all the difference and the similarity between carbon dioxide and sulfur dioxide. Moving to next is hydrogen sulfide gas. Colorless gas, rotten egg smell, turns more. Now, the specific odor of this gas is it smells like rotten egg. So, the smell of rotten egg confirms the presence of hydrogen sulfide. Now, hydrogen sulfide turns moist lead acetate paper silvery black. You can see here the color you can see here, right? This is your lead acetate paper, which turns silvery black because of the presence of hydrogen sulfide gas. And with the solution, you get a black precipitate. Now, this black precipitate is because of the formation of lead sulphide, which is black in color. You can see the reaction also. This is lead acetate. Lead acetate reacts with hydrogen sulfide to form acetic acid and lead sulfide, which is black color precipitate. Similarly, when lead nitrate solution is treated with H2S, then also you have the formation of a black precipitate along with nitric acid. Okay, so this is the two important tests, you can say, a chemical test to confirm the presence of hydrogen sulfide. Now, test of the gas, you can see here, black PPT is obtained when passes through lead acetate solution. You can also see that when it is passed over a moist lead acetate paper, it turns silvery black. That is also an observation. Then acidified potassium permanganate turns colorless with yellow particles suspended in it. There are yellow particles suspended in the colorless solution. That yellow particle is because of the presence of sulfur. Okay, so this is actually a point of difference between sulfur dioxide and hydrogen sulfide, because sulfur dioxide produces a clear transparent solution of potassium permanganate after decolorizing it, and here in potassium dichromate it produces clear green solution, but with hydrogen sulfide you get yellow particles suspended in it. So that differentiates between sulfur dioxide and hydrogen sulfide. So what is the observation? Colorless gas with rotten egg smell turns lead acetate paper silvery black, decolorizes potassium permanganate, turns orange potassium dichromate solution, and in both cases with yellow particles suspended in it. It's very important. Okay, yellow particles suspended in it, very important. Moving to the next, here are certain reactions which you can see where you have the formation of hydrogen sulfide. So any metal sulfide, now sodium sulfide, zinc sulfide, potassium sulfide, iron sulfide, copper sulfide, they all react with acids, dilute acids, to produce the respective salt and H2S gas. Okay, so in all the cases, you can find you have to heat it a little sometimes to get the reaction faster in the lab, and you have a specific rotten egg smell that is being, what to say, you must have experienced this in your labs, right? So that is how the H2S gas is produced. So this is how the gas is produced in the lab. And how will you test it? Lead acetate paper, or you use lead acetate solution, or you use lead nitrate solution. You will get black precipitate, and even the lead acetate paper turns silvery black. Very good. And also, when you treat it with potassium permanganate or potassium dichromate, it decolorizes potassium permanganate with yellow particles suspended in it, and it also changes the color of orange dichromate, potassium dichromate solution into green solution with suspended yellow particles. That confirms the presence of hydrogen sulfide. Next gas is nitrogen dioxide. Nitrogen dioxide has a specific color, reddish brown color. It has a pungent odor because this is also an acidic gas which reacts with the moisture present in your nose, gives you a tingling sensation in the nose because of the formation of nitrous acid and nitric acid. And it turns moist potassium iodide paper, Ki paper, brown, and at the same time it turns acidified ferrous sulfate. Ferrous sulfate is greenish in color. It turns brown. So you can see here the ferrous sulfate solution turns brown and the Ki paper also turns brown. So remember, brown, reddish brown gas is turning everything brown, right? So this is easy to remember. How is this gas prepared? This gas is prepared by thermal decomposition of nitrates. This we have already done with oxygen, because here you have an extra gas produced, which is oxygen. And here reddish brown gas is released, which will turn moist blue litmus red, showing that it is acidic in nature. It also turns the Ki paper brown, and it also turns the greenish ferrous sulfate into a brown, in a brown PPT is formed. Okay, so you can see here now all the gases. This is already, we have done it once. You can write the reactions. Generally, all the divalent metals, copper, calcium, lead, zinc, magnesium, reaction is easy to remember. You have the oxides formed plus 4NO2 plus O2. So this is how the reaction is. Balancing will be easy. right? Then you have metals and non-metals when they react with concentrated nitric acid. Now, concentrated nitric acid gives you a yellow color, gives you a blue color solution, correct? Now, this blue color solution also the release of the reddish brown gas. The only difference between the concentrated nitric acid and dilute nitric acid is the formation of the gas. In case of dilute nitric acid, you have nitrogen, that is NO, that is nitrogen monoxide is formed, right? Nitrogen monoxide is formed. You can nitric oxide is formed, not nitrogen dioxide is formed. Nitric oxide is formed, and the non-metals like carbon and sulfur, when they react with the nitric concentrated nitric acid, you have the formation of carbon dioxide, water, and the reddish brown gas, which is nitrogen dioxide. Okay, difference between the reaction of concentrated nitric acid and dilute nitric acid is to be known. Then you Now moving to chlorine gas, you can see here that chlorine gas is actually a greenish yellow color gas, and it has a pungent and choking odor. Have you ever experienced the smell in the swimming pool just after cleaning? There's a pungent kind of odor, no? That is because of the chlorine gas. It is an acidic gas and it turns moist starch iodide paper blue-black. Remember, chlorine, greenish yellow gas turns starch iodide paper. There it was lead iodide paper, right? Here it is starch iodide paper, which turns blue-black. And even with the litmus paper, it first turns blue litmus red, showing that it is acidic in nature. After that, it bleaches, showing its effect, right? That is chlorine gas bleaches the paper later. Moving to the next. These are the preparation of gases. How can you prepare the gas? Now here children, chlorine gas is prepared by heating oxidizing agents with concentrated hydrochloric acid. Now oxidizing agent means what? Which itself gets reduced. Now here MnO2 is an oxidizing agent and it oxidizes HCl, that is oxidizes H2 water and chlorine gas is released. Itself, it gets reduced, right? So this is what um, reaction is all about. That is any oxidizing agent you can see here. Lead oxide, when treated with concentrated HCl, gives you lead chloride, water, and chlorine gas. Then KMnO4, that is potassium permanganate, with HCl gives you KCl, MnCl2, and H2O, and chlorine gas. These are certain complex reactions. Means bigger reactions with bigger numbers of balancing. So you should know these. Potassium dichromate, when treated with HCl, gives you KCl. Chromium chloride, that is green in color. Here it is orange and it forms green solution. And then you have the chlorine gas is released. So this is how chlorine gas is prepared, right? Other ways of preparation of chlorine gases, it is this, though I have already discussed, right? This I have already discussed. That is concentrated HCl with MnO2. Then action of HCl on bleaching powder. Bleaching powder is CaOCl2. When it is treated with dilute HCl, it forms calcium chloride, water, and chlorine gas is released. Then it is also produced in industries by electrolysis of brine. What is brine? A salt solution. So salt solution, aqueous solution of sodium chloride, when it is electrolyzed, you have the formation of chlorine gas at the anode. This is how the gas is prepared in the industries. Okay. Then next one is hydrogen chloride gas, HCl gas. It is again a colorless gas with a pungent irritating odor. It is acidic. HCl is acidic. When a rod dipped in ammonia is brought near the gas, dense white fume is observed or produced. Now, this dense white fume is because of the formation of ammonium chloride. So, hydrochloric acid or HCl gas reacts with ammonia to form ammonium chloride, which is dense white. That is the formation of dense white fume. Then when hydrogen chloride gas is passed through silver nitrate, it produces a curdy white precipitate soluble in ammonium hydroxide and insoluble in nitric acid. So you can see here AgCl is insoluble in nitric acid. That is why it is forming a precipitate. But when you add this precipitate to ammonium hydroxide, it will get dissolved in it. Understood. So always remember here, whenever you have a precipitate formation, that means that that salt is insoluble in the other thing which is formed along with it. So here nitric acid is formed. So AgCl does not dissolve in it. It's insoluble in nitric acid, but same PPT can dissolve in ammonium hydroxide. When hydrogen chloride gas is passed through lead nitrate, you have the formation of a white precipitate, which is soluble in hot water and insoluble in nitric acid. Here also it is insoluble in nitric acid and it is soluble in hot water. You take out the precipitate, put it in hot water, it will get dissolved. So this is again a test for HCl gas. How it is prepared? It is prepared by metallic chloride or ammonium chloride is boiled with concentrated sulfuric acid. So here you can see NaCl when boiled with H2SO4 at temperature more, that is temperature is less than 200 degrees centigrade, you have the formation of bisulfate. But when the temperature is greater than equal to 200 degrees centigrade, you have the formation of sulfate. So this is temperature ka difference. When it is less than 200, you have bisulfate formation. Along with the HCl gas, when you have more than 200 degrees centigrade, you have the formation of sulfate along with the HCl gas. Then HCl concentrated H2SO, same, you can see potassium bisulfate is formed along with the HCl gas, and if the temperature is greater than 200 degrees centigrade or equal to 200 degrees centigrade, you have the formation of sulfate along with HCl gas. This is how HCl gas is produced. Okay, next one is ammonia. We have talked about HCl, which was an acidic gas. Now let us talk about ammonia, which is a basic gas. It is again a colorless gas. It has a very specific kind of odor. I hope you have all been close to the public washroom sometimes. There is a pungent odor that comes from that place because of ammonia. And how is ammonia produced there? Urine contains urea. Urea decomposes into ammonia and carbon dioxide when it is left. That is the reason why that pungent smell of ammonia is felt if the washroom is not flushed properly or near the public washroom areas. Coming back from biology to chemistry, it is a colorless, odorless gas. It is a colorless gas with a pungent odor, and it is basic. Basic means it turns moist red litmus blue. B for basic, B for blue. And when a rod dipped in concentrated hydrochloric acid is brought near the gas, dense white fume is produced. The same test as for HCl gas. So you have NH4Cl, dense white fumes being produced. So this is a test for ammonia gas. So when ammonia gas is passed through the Nessler's reagent. What is Nessler's reagent? It's a potassium tetraiodiomercurate complex. It's a coordinate compound, you can say. It's a complex. You can just understand complex compound. It gives a brown precipitate. This formation of brown precipitate confirms the presence of ammonia gas. Then again, ammonia gas is passed through copper sulfate solution. It gives a pale blue precipitate. When excess of ammonia gas is passed, a pale blue precipitate dissolves, giving inky blue solution. Now, this test we have already understood or done with the cation analysis of copper ions. When copper ion is to be analyzed, we use NH4OH. That is, NH4OH is what? Ammonia in water. So when copper ions are treated with ammonium hydroxide, it gives pale blue precipitate. When you add excess of NH4OH, it dissolves to form an inky blue solution. But this does not happen with NaOH or sodium hydroxide solution. Understood? Remember? This also is the kind of test similar to it, because here also ammonia is going into copper sulfate solution, reacting with the water present there, forming NH4OH only and the formation of pale blue precipitate. Now this precipitate dissolves in excess of ammonium hydroxide to give you an inky blue solution. So this is again a test for ammonia gas. So you can use it for cation analysis as well as you can use it for the test of ammonia gas, that is copper ions, copper nitrate, copper sulfate solution. How is this gas produced? This gas is produced whenever any ammonium salt is heated with an alkali. Ammonium chloride, ammonium sulfate, when heated with calcium hydroxide, sodium hydroxide, potassium hydroxide, they give you ammonia gas along with the formation of salt and water. So you have salt, water plus ammonia gas formed. When you have the chlorides, you have calcium chloride, sodium chloride, potassium chloride. When you have sulfates, you have calcium sulfate, sodium sulfate, potassium sulfate. The reactions are all similar. If you know this part, that whenever an ammonium salt is heated with an alkali, you have the formation of salt, water, and ammonia gas. You can write as many reactions you want, right? So write these reactions, it will be helpful. Metal nitride when treated with warm water. Then you have formation of metal hydroxide and ammonia gas. You can see here calcium nitride, magnesium nitride, aluminum nitride. When they react with water, warm water, they form their respective hydroxides and the ammonia gas. Correct. So, and alkaline earth metal nitrides, this is alkaline earth metals, that is group 2. Right? So the question can be, why not group 1? Group 1 also forms nitride. No, group 1's nitrides are not stable. Exception is lithium nitride. Because of their size, they cannot form nitrides, stable nitrides, except for lithium nitride. And lithium nitride reacts with warm water to form lithium hydroxide and ammonia. This is an exception, okay? This is an exception. Otherwise, all alkaline earth metal nitrides, they react with warm water to give metal hydroxide and ammonia. Then this is the summary of whatever gases we did. Hydrogen, colorless, odorless, neutral gas, which burns with a pop sound. And you can also add it, it burns with a pop sound, and the glowing splint, no, it extinguishes. It's a non-supporter of combustion also. Oxygen is a colorless, odorless, neutral gas, which rekindles the glowing splint, also turns alkaline paragalol solution brown. Carbon dioxide is a colorless, odorless, acidic gas which turns lime water milky, no effect on acidified potassium permanganate and potassium dichromate solution. Sulfur dioxide is colorless, odorless gas, acidic gas. It turns acidic means you can say moist blue litmus turning red, turns lime water milky, turns acidified potassium permanganate pink to colorless, and potassium dichromate solution orange to clear green. Always remember it should be clear green because H2S has yellow particles suspended. It's not a clear solution. But in case of sulfur dioxide, it's a clear solution. Hydrogen disulfide H2S, colorless gas with a rotten egg smell. It is acidic and it turns moist lead acetate paper silvery black, turns acidified potassium permanganate pink to colorless with yellow particles suspended in it, and potassium dichromate orange to green with yellow particles suspended in it. Chlorine gas is a greenish yellow gas with a pungent choking smell. It is acidic. The greenish yellow gas released turns moist starch iodide paper blue-black, turns moist blue litmus red and then bleaches it. Hydrogen chloride gas is a colorless gas with a pungent irritating odor, acidic. When rod dipped in ammonia solution is brought near the HCl gas, dense white fume of ammonium chloride is produced. Nitrogen dioxide is a reddish-brown gas with a pungent, irritating odor. It is acidic, reddish-brown gas released which turns moist potassium iodide paper brown and acidified ferrous sulfate green to brown. This gives you the test. For standard 7, this table is more than enough. For standard 8 and 9, you can see the reactions, learn the reactions. For standard 7 also, you can practice these reactions. Balancing of the reactions can be learned from these set of reactions given in this presentation. Right? So it's not specific to any class. If you want to learn practical chemistry, understand about the colors, you can easily refer to the slides, share with your friends, and let me know in the comment section, how did you feel after going through this presentation? It really motivates me, children, to make something more. And also write in the comment section that what video you want me to make so that it can help you to understand chemistry better, love the subject, then only you will like the subject. So, and for loving and liking the subject, you need to understand the subject, right? Ammonia, colorless, pungent, irritating smell, basic. When rod dipped in concentrated hydrochloric acid is brought near the ammonia gas, dense white fumes of ammonium chloride is produced. Ammonia gas, when passed through Nessler's reagent, gives a brown precipitate. This is what all about the important gases, their test, their reactions. Okay, I hope you enjoyed learning chemistry because now chemistry must be making sense with you, right? Happy learning, children. Be connected with BioWise and let me know what you want to learn next. Thank you so much.